Fernanda again. I hope you're not sick of me quite yet. I want to go ahead and welcome you back to GED On. On today's video, we will be covering part 2 of chapter 4, Data, Statistics, and Probability. As you may recall, this is a very long chapter, therefore we felt it was best to split it into 2 parts. It's very important that you take the time to watch part 1 before commencing part 2. As always, you are more than welcome to pause and replay this video at any time. Now, let's go ahead and get started with our very first lesson. I wish you the best of luck. Like always, we will be utilizing the Kaplan GED Test Prep Plus 2020 book for this and all GED On videos. You can find links below to purchase this book at your local store or online. Now, let's go ahead and get started. On today's video, we're going to be covering Unit 2, Mathematical Reasoning, Chapter 4, Data, Statistics, and Probability, Part 2. We will be reviewing lessons 5 through 10, which start on page 292. As you already know, because Chapter 4 is fairly long, we went ahead and split it into 2 parts, so please ensure to watch Part 1 before starting this video. If you have done so already, then let's go ahead and get started. Up next, Lesson 5, Line Plots. Let's go ahead and move on to line plots. So a line plot is very similar to a number line in the sense that it looks visually the same, except that it represents a different set of information. So a line plot is utilized to showcase the frequency of data along a number line. So it's meant to visually portray how often something takes place through the lens of a number line. So let's look at an example. Example 1. The Student Health Services Department at a university surveyed several students and asked them how many times per week they visited the school's gym. This particular table with 2 different columns of information represents weekly gym visits and the number of students that actually visit the gym. If we were to take the information from this table and put it into a line plot, it would look like this. So visually, you will notice it looks just like a number line with the 2 arrows at the end, and in this particular case, it has also digits, whole numbers, that range from 0 to 7. The tiny X's above each mark or each digit represent the number of students that visited per week. If we want to look at the distribution or the arrangement of data on this line plot, we can notice that it is an uneven distribution because there is not the same number of X marks across each digit. So we don't see the same number of X's from 0 to 7. So they vary from 0 to 3. Now, we can see that the highest frequency of visits is 3. If we look at our line plot, the number that has the most X's is 3. So therefore, it's the highest frequency. Lastly, the range. The range covers the entire set of information from beginning to end, from smallest to largest, from least to most. In this case, the range is 0 to 7 visits per week. Let's look at another example of a line plot and try to solve that problem together. Okay, example 2. Students in Miss Jones's class took a math test. Their scores on the test are displayed on the line plot below. Each dot represents a student. Which grade displayed the highest frequency? So let's look at our line plot. So instead of X's on this one, we have dots, and instead of digits, we have grades. So remember that the highest frequency is the one that we have the most of. So we notice that under F, we do not have any test scores, or no dots. D, we have 3. For the grade of C, we have 1, 2, 3, 4, 5, 6. For B, we have 1, 2, 3, 4, 5. And for A, we have 2. Visually, we can determine that the grade that's displayed with the most frequency is the grade of C. Thus, this is our final answer. More students received a grade of C than any other grade. We are now moving on to practice 5, found on page 293. For practice 5, go ahead and pause the video, choose the histogram that matches each frequency table, using choices A through D below for both questions 1 and 2. Once you've solved for these questions, go ahead and click play. Let's look at our first question of practice 5. Zoologists have counted the number of stripes on certain zebras in a zoo. The set of data from these observations is represented by the following frequency table. So it's asking us to find the line plot that aligns with our frequency table. So we have 4 different options. So we can actually go ahead and determine which ones are not the right answer, even by just looking at the first bit of information on the frequency table. So we can see that for the first one, the first set of information on the row, we have 24 stripes per side, with only one zebra having that same number of stripes. If we look at the line plots that we have been provided, we can see that both answers A and B have no X's over the digit 24. That doesn't match our frequency table, so we can automatically know that A and B cannot be the right answer. So that leaves us with 2 options, C and D, both of which have 1X over 24. Let's look at the second row of our frequency table. The second row states that we have 25 number of stripes per side and that 0 zebras have that many stripes. So looking at options C and D, we know that answer D cannot be correct as it has 1X over the digit of 25, meaning that on that line plot, it states that one zebra does have 25 stripes per side, but our frequency table does not match that. But let's go ahead and look at C just in case to confirm. So again, we have 1X over 24, which matches our frequency table. We have no X's over 25, which matches our frequency table. We have 26 number of stripes per side, which is the next row, with 2 numbers of zebras that have those stripes, which matches the line plot of option C. And if we keep going, we can see that option C is the one that aligns most with the frequency table. Therefore, answer C is our final answer. Let's take a look at another example. Okay, question 2. At a certain elementary school, classes may have different numbers of students. The following frequency table represents how many students are in the classes this year. So we have to find a number plot that aligns with our frequency table. So let's go ahead and start from the very beginning, kind of like we did before. So in our first row of information, we have a number of students, which is 24. If we look across, we see that the number of classes with that many students is 0. So just based off that row alone, we can eliminate some possible answers. So we're going to want to look for a number plot that does not have 0 classes with 24 students. So visually, I can see that answers C and D cannot be plausible answers for this question because they have an X or a tally mark above the number 24. This leaves us with options A and B. So let's look at the next row of information. We have 25 students and 0 classes with that number of students. So if we look at options A and B, we can see that A cannot be a possible answer as it has an X or a tally mark above the number 25. This leaves us with an option of B. But let's go ahead and look at another row just to make sure that this is the correct answer. So if I look at my frequency table, we see that the third row claims that 26 number of students can be found in 0 classes. So we have 0 classes that have just 26 students in them. So that matches the line plot for option B. Next row, we have one classroom that has 27 students. That also matches our line plot for option B. If we were to keep going, we would notice that option B or answer B matches the information that's in our frequency table. Therefore, our correct answer is B. Alrighty everyone, at this time, pause the video, complete practice questions 3 and 4, and click play when you're ready to move on. We are cruising right along. Now, let's go ahead and start Lesson 6, Histograms. Okay, now we're on histograms. So histograms are created and utilized to display frequency across a series of data points. Let's look at this example. Example 1. Graham is a veterinarian. Last year, he decided to track client appointments for spring shots. So you can see that we have our table here that represents a series of weeks in what looks like 7-day increments. It also shows how many appointments were made during each week. If we look at our histogram to the side or on the right-hand side of the screen, it looks very similar to a bar graph and everything else that we really have covered throughout this particular chapter. So we can see that it has a vertical axis, also called a y-axis, which represents the number of appointments per each week. We can also see that the number of appointments are built upon in 5-digit increments. The histogram also has a horizontal axis, which we can see represents each week. Now, the area of the bar is reflective of how many numbers of appointments there were per each series of weeks. So this entire histogram represents essentially his entire spring at his clinic. So let's dive a little bit deeper by looking at another example. Alrighty, let's look at example 2. What percent of appointments for spring shots occurred during the first 2 weeks of March? So we can see by our histogram that we have both a y and an x-axis. For the y-axis, that represents percent of appointments. It's also in increments of 5. For the x-axis, that is representative of particular dates by week. So let's go ahead and look at week 1 and week 2. We know that the bar in which it states March 1 is actually really reflective of March 1 through 7, while the bar for March 8 actually represents March 8 through the 14th. And you can just see that based on the fact that each increment of dates increases by a total of 7 days. So for this particular problem, we're going to want to add. So for March 1st to March 7th, we have approximately 2% of appointments. For the second week of March, we have around 5%. Again, we can see that by looking at the bars that represent the percent of appointments per week. So in order for us to get the total percent of appointments that occurred during the first 2 weeks of March, we're going to want to add these two amounts. So if we add 2% plus 5%, we get a final answer of 7%. So there is 7% of appointments that occurred during the first 2 weeks of March. Let's move on to practice 6, found on page 295. Pause the video and choose the histogram that matches each frequency table. Use choices A through D below for both questions 1 and 2. Once you've solved for these two questions, go ahead and click play so that we can review them together. Okay, we're now moving on to the first question of practice 6. Josefina runs a retail business. She posted a coupon to a social media site from 9 a.m. to 5 p.m. The table shows how many people downloaded or printed the coupon. So this is asking us to pick the best option of histogram to align with the table of information that we would provide it. This is super similar to what we did before with line plots. So let's look at the information that was provided on our table and find the best histogram that aligns with that information. Similarly, we can also find the answer through the process of elimination. Let's start by looking at row 1. At 9 a.m., 30 people either downloaded or printed the coupon. So if we look at our histograms, let's go ahead and look for one in which 30 people signed up, downloaded, or printed the coupon at 9 a.m. Now you'll notice that these histograms don't actually have time frames listed under the x-axis. However, we're going to go ahead and pretend like the first bar is 9, the second bar is 10, the third 11, and so on. So looking at the very first bar all the way to the left of each histogram, let's find one that matches with 30. So we see that it can't be A, as the first digit on there is 20. It cannot be B, as it looks like that number might be 15. So that leaves us with C and D. So in the case of C, we can see that the first bar does go up to 30. Option D does not. So right now, I'm thinking that C is the correct answer, but let's go ahead and double check just in case. So let's look at the next row. At 10 o'clock, 56 people downloaded or printed the coupon. So we're going to look at the second bar of the histogram in letter C, or answer C. So if we look at the second bar, we can see that the bar goes past 55 just a little bit. So it's about 56. So again, that aligns with our answer C, but let's look at one more just in case. So in the row of 11 a.m., we can see that 80 people downloaded or printed the coupon. If we look at our answer C histogram, we can see that in fact, the third bar does go up to 80. Therefore, we can now determine that C is in fact our correct answer. Okay, question 2. Mike administered a skills assessment to his employees. Possible scores on the skills assessment range from 200 to 1800. That's a big gap. But essentially, we're going to do the exact same thing as we did before. We're going to find the histogram that best aligns with the provided data on our table. So we can see that our data has two columns, score range and number of employees. So let's use our process of elimination to solve this. So if we're looking at our first row, we have 200 to 399. Then we have number of employees as 15. So in this particular case, the y-axis is going to represent the number of employees. The score range is that missing x-axis. But again, we're going to pretend that each bar is reflective of each one of those numbers or score ranges. So let's look at our histograms and see which bar represents 15. Or we can find which one doesn't and eliminate them. So visually, I can see that option A cannot be the correct answer as the first bar goes up to 20. Option B might be the correct answer as we can see that it does go up to 15. But let's keep going. Option C is not a viable answer as the first bar goes up to 30, so that one's out as well. Option D also goes up to 15. So at this point, we have two possible answers. We have answer B and answer D. So let's look at the next row of information in order to further determine. The next score range is 400 to 599. The number of employees is 22. So looking at our options of B and D, let's see which one has the bar or the second bar that goes up to 22. So just looking at it, this is a little tricky, but it looks like they both go up to 22 or around that same amount. So let's look at the third row just to further break it down. So our third score range is 600 to 799. Number of employees is 35. So if I look at the third bar in B and D, I can see that B does not go up to 35, and it actually looks like it goes up to a little under 30, but option D does in fact go up to 35. Let's look at one more row just in case. So we have our fourth row, which is 800 to 999. The number of employees that scored that were 62. So at this point, I'm thinking that D might be the correct answer, but let's just double check. So if we count to the fourth bar, we can see that it does in fact go up to about 62. If I look at the next bar, it goes up to 80, which matches the number of employees in that next row of information. If I were to keep going, it does in fact keep lining up. So at this point, we can determine that our correct answer for this question is option D. Now that we have worked through questions 1 and 2 of practice 6, go ahead and pause the video to complete practice question 3. Once you've solved for this practice question, click play to move on to the next lesson. Let's move on to lesson 7, probability. Alrighty everyone, we're getting close to the end, so we have a few lessons left. But let's go ahead and start off with lesson 7, probability. We'll start off with simple probability. So probability is a ratio, which can be expressed as a ratio, a fraction, a decimal, or a percentage. In the sense of simple probability, it can be expressed by a number ranging from 0 to 1. The probability of 0 technically equals impossible, while the probability of 1 is possible or certain. So what does that really mean? This means that in the sense of probability, we have 3 different outcomes. We have the favorable outcome, which is the event or result which is desired, a possible outcome, which is the range of possibilities that can take place or occur, and of course, the theoretical simple probability, the ratio of favorable outcomes to possible outcomes. So one of the things that comes to mind when I think of probability is a set of dice. You never really know exactly what you might get, but you do have a series of possible outcomes. So if you're one of those people that loves to gamble or loves to play games, I'm sure you are very familiar with the sense of probability, which is essentially the strategy that a lot of these players utilize in order to have favorable outcomes. So let's go ahead and look at an example of this and dive a little bit deeper into what each of these 3 things mean. Let's start this lesson by looking at our first example. Example 1. The spinner is divided into 8 equal sections. What is the probability of spinning a number 4 on the spinner? So we're going to follow a series of steps, really just 2, in order to solve this problem. So let's start with step 1. Count the number of times the desired probability is presented. Then count the number of available sections. Step 2, use probability ratio, and remember it's favorable outcomes over possible outcomes. So in this particular case, we're looking to see what the probability is that the spinner will give us a number 4. So we have a total of 8 sections in this particular spinner, 8 slices, so to speak. We have a total number of desired numbers 4, which if you look at it, appears twice on the spinner. Therefore, we technically have 2 number 4s. So out of these 8 particular sections, what is the chance that we're going to land on one of those number 4s? So we're going to put our favorable outcomes over possible outcomes. So we have 8 sections, which is possible outcomes, and 2 favorable outcomes. Now, it's not the number 4 because that's just an item. The number 4 could be, any other number. It could be a symbol. It could be anything else. We're just looking at how many times it appears. Hence, why we put 2 in the numerator. So if we have 2 over 8, we can then further break that down to 1 over 4, as both 2 and 8 have a multiple of 2. So all we did was divide both 2 and 8 by 2. So if we take 1 over 4, that means that 1 out of every 4 spins is going to give us the number 4. Okay, so 1 over 4 or 1 out of 4 can also be displayed as 0.25 as a decimal, or of course 25%. Now let's look at example 2. Ricardo and Scott used the same spinner to play a game. They kept track of the numbers that they got on each spin for 20 spins. The numbers are shown below. Based on their results, what is the experimental probability of spinning a 4? So here we can see all of the numbers that they spun, and we can see that a couple of numbers actually occur a couple different times. So let's solve this using our steps. So step 1, count the number of times the desired probability is presented. Then count the number of available sections. So in this case, our desired probability is a number 4. Then we're going to follow step 2. Use probability ratio. So we're going to put our favorable outcomes over our possible outcomes. So we have a total number of sections or numbers, which is 20. So we were given 20 numbers for the 20 spins. Now, our desired outcome of 4 was spun 6 out of those 20 times. So let's use this information and plug it into our formula. So our favorable outcomes is 6. Again, remember, it's not actually the number 4 because that's relevant. We're just counting the number of times it appears. Then we're going to put it over our possible outcomes, which is 20. Our possible outcomes are always the same as the number of times something took place. So if we have 6 over 20, we can further reduce that to 3 over 10, as both 6 and 20 share a multiple of 2. 3 over 10 then actually equals 3 out of 10 times. So 3 out of 10 times, or 3 out of 10 spins, we're going to get the number 4. We can then further put this into a decimal, which would be 0.3, or if we want a percentage, it would be 30%. Let's go ahead and try and use what we just learned to complete practice 7, found on page 297. Go ahead and pause the video and follow these instructions. Express probability as a fraction, decimal, and percent for questions 1 and 3. Do not use a calculator. Once you have worked through these questions, go ahead and click play so that we can review them together. Let's go ahead and look at our practice questions from practice 7. For each of these questions, we are going to want to find the fraction, decimal, and percentage answer. Starting with question 1. A game has 50 wooden tiles. Players draw tiles to spell words. If 20 of the tiles are marked with vowels, what is the probability of drawing a vowel from the tiles? So for these two questions, we're actually going to provide you with the answers, but we're going to work through them so you can see how we got here. So we're going to use our same formula. We have favorable outcomes over possible outcomes. So we know that we have a total of 50 wooden tiles. So we have technically 50 possible outcomes. However, we want to look at our favorable outcomes, which is 20. So we're going to put 20 over 50, which can then be further reduced to 2 over 5, as they both share a multiple of 10. So we're just dividing each of those by 10. Now, if we have 2 over 5, that's going to be our fraction answer, but we can actually turn that into a decimal by dividing 2 by 5. That gives us an answer of 0.4, and of course the percentage of that would be 40%. Question 3. There are 4 red, 4 blue, and 2 green marbles in a bag. If one marble is chosen at random from the bag, what is the probability that the marble will be green? So same process. We know that by adding 4 plus 4 plus 2, we have 10, which is our possible outcomes. But we want to know what the outcome is of one of those marbles being green. So we know that we have 2 green marbles in the bag, which is our favorable outcome. So if we're going to put this into our formula, we have 2 over 10, which reduces to 1 over 5, as they both have a multiple of 2, which then you can get the decimal of 0.2. We get that decimal by dividing 1 by 5. 0.2 turned into a percentage is then 20%. Now that we have worked through questions 1 and 3, go ahead and pause the video once again and complete questions that are remaining from sections A and B. Click play when you're ready to continue. Let's go ahead and move forward to example 3. That states, Brad tosses 2 quarters into the air. What is the probability that both will land so that the head sides are showing? So one way to solve this problem is to list or diagram all the possible outcomes. So right here we kind of have a little diagram of what could take place. So you'll notice that we have 2 sections. If quarter 1 is heads, we have 2 possibilities of quarter 2 could be heads, which would give us HH or 2 heads, or quarter 2 could be tails. So we have heads and tails. Now, second quarter. If quarter number 1 is tails, we have 2 other possible outcomes. That would mean that quarter 2 could be heads, which would give us TH, as in tails and heads, or quarter number 2 could be tails, giving us TT. So for step 1, what we're going to want to do is to find the probability of the individual events, which we already did. The probability that one coin will be heads is 1/2. So what does that mean? If you look at a coin, it literally does have 1/2 being heads and 1/2 being tails. So when you flip a coin, there is literally only half a chance that you could get one or the other. Now, let's keep reading on the sentence. If the probability that one coin will be heads is 1/2, and the probability that the other will also be 1/2, we can find the probability of both events by multiplying them together. So if we have 1/2 times 1/2, that gives us 1/4. So 1/4 is going to be the probability that both will land so the head sides are showing. So let's kind of take it back. We have 4 possible outcomes and only one is favorable, which is HH. You can see that at the very top of our diagram. Therefore, again, the probability of having both land with heads up is 1/4, or 25% of those tosses. Example 4. A box contains 4 blue marbles and 2 red marbles. If you select 2 marbles, what is the probability that both will be blue? So this is our little diagram. So the ones that are a little bit of a darker shade or a black shade, let's pretend that those are blue and the lighter ones are red. So there are 6 marbles in each box, and 4 are blue. The probability that the marble will be blue is 4/6. This reduces to 2/3. So how do we know this? If we look at the box at the very top that has the 6 marbles, we can see that the total amount or the possible outcomes would be 6, which is why it's in our denominator, while the favorable outcomes is 4, since there are 4 blue marbles. This reduces to 2/3 because both 4 and 6 have a multiple of 2 in common, so we're just reducing it. So now, we're going to pretend that the first marble selected is blue, so we kind of took one out. So let's look at the second box. There are now only 5 marbles in the box, and 3 of them are blue. So we're going to do the exact same thing. Thus, the probability that the second marble will be blue is 3/5. 5 because we only have 5 left, so possible outcomes, and 3 because we have 3 blue marbles. And again, that's the desired outcome. So now we have 2/3 and 3/5, and we're looking at the entire probability. So what we're going to want to do is to multiply both events with one another to find the probability of both events. So if we take 2/3 times 3/5, that gives us 6/15, which share a multiple of 3. So if we divide both 6 and 15 by 3, that gives us a final answer of 2/5. All right, everyone, I know that lesson 7 is a long one, but we're going to go ahead and keep it moving to practice 7.2 found on page 299. For practice 7.2, questions 1 and 2, solve as directed and express your answers as fractions. Go ahead and pause the video to complete these questions. Once you're ready to move forward, click play. So lesson 7 is a pretty long one as we have another section of practice questions. So let's go ahead and get started. We have 2 questions. Number 1, Kim rolls 2 standard 6-sided dice. What is the chance that both will be 4s? So we have 2 separate dice. The event of both dice being rolled are independent from one another as they are 2 separate events. So that's just something important for you to keep in mind. Now, we're going to use our same method as we did before, except that we're going to treat each dice as its own separate formula. So we're going to put our possible outcomes in the denominator. For each of those dice, the possible outcome is 6, as it is a 6-sided dice. Our favorable outcomes is going to be 1, because there is only one side of each dice that has 4 dots. So we're going to multiply 1/6, which is one dice, times 1/6, which is the other dice. That gives us a total of 1/36. So what does that mean? That means that 1 out of 36 times, the dice will give us both 4s. Question 2. 10 cards are numbered from 1 to 10. Tony draws out a card, replaces it, and then draws another card. What is the probability that both cards will be numbers greater than 5? So because the first card was replaced, both card draws are independent of one another, kind of like with question 1. The cards that are greater than 5 are 6, 7, 8, 9, and 10. Therefore, we have a possible outcomes of 10, since we have 10 cards. Now we're looking at the probability that numbers are going to be greater than 5. We have 5 numbers that are greater than 5, which are that 6 through 10. So when you see the 5s in the numerator, that is not at all aligned with the actual number 5 that's listed in the question. This is just reflecting how many numbers are left out of those 10 cards that are greater than 5. So because we have 2 cards, we're multiplying 2 different probabilities together. So we have 5 over 10 multiplied by 5 over 10, which then gives us, or is equal to, 1 over 2 times 1 over 2. So you could just multiply 5 over 10 times 5 over 10 and then reduce. Or you can just reduce beforehand and multiply across. Either way, at its fully reduced fraction, the final answer is still going to be 1 over 4. At this time, pause the video and complete the remaining questions for sections A and B. Once those are completed, click play to move forward. We are now moving on to Lesson 8, Combinations. When you take the GED Mathematical Reasoning Test, it might ask you how many ways you can combine a set of items. There might be moments when you only have one type of item to combine, and at other times you may have more than one type to combine. So what does this actually mean? It might actually be easier to explain this using an example. Example 1. Pablo is going shopping at a fruit stand that sells apples, bananas, grapes, and pears. Pablo will buy 2 different kinds of fruits. How many combinations of 2 kinds of fruits could Pablo buy? So, we're going to represent each of these fruits by using letters. So A obviously is for apple, B for banana, G for grapes, and P for pears. So if we want to determine how many different combinations we can utilize, we can actually look at just one type of fruit and then create a table. In this case, we're going to look at how many different combinations we can make with apples. Given that there are 3 other types of fruit besides apples, it makes sense that we could only realistically make 3 combinations with apples. So we have apples and bananas, apples and grapes, and apples and pears. Now, if I want to look at bananas, you can combine a banana with 3 other types of fruits. So you can do bananas and apples, bananas and grapes, and bananas and pears. However, an apple-banana combination is the exact same thing as a banana-apple combination. So we don't want to double dip. We don't want to count that twice. So we're only going to count it once. Now moving on to grapes, you can combine grapes with pears, grapes with bananas, and grapes with apples. But again, you only want to count something once. So doing that for each of those 4 different fruits actually gives us a total of 6 different possible combinations of fruits that Pablo can buy. Let's kind of keep practicing with this particular lesson and look at another example. Let's move on to practice 8.1, found on page 301. At this time, go ahead and pause the video and follow these instructions. Use counting an organized list or a table to solve the following problems. Once you've solved for both questions 1 and 2, go ahead and click play. Alrighty, let's look at our first question. As a supervisor, Rob is choosing 4 of his employees to work on a special project. The employees are Angela, Barbara, Colin, David, and Elizabeth. Of those 5 employees, how many teams of 4 are possible? So we have 5 employees total. That means that for each group of 4, one person is automatically going to get left out. Now, since Rob is choosing 4 team members, each possible created team again leaves out 1 employee. Given that there are 5 employees, you can actually create 5 possible teams. Question 2. Jessica wants to take 3 books on vacation with her. She has 5 books to choose from. How many possible combinations of 3 books could she take on vacation? So this is kind of similar to that fruit example or the fruit stand. So let's go ahead and look at a table of this. So we have a total of 5 books to choose from, but we have 3 books that we want to take. So each of these letters represents a different book. So we're just going to pretend. So similar to the fruit example, we're going to go ahead and do combinations, but make sure that we don't count something twice. So we can do a combination of ABC, ABD, and ABE. These are combinations of A and B. Combinations of A and C would be ACD and ACE, and so on, and so on, and so on. So if we're looking at these particular combinations, you'll also notice that in the table we do have some blank spots. So typically these blank spots are where we would put the reverse of something that's already previously been stated. So kind of like our prior example, we are not going to do or count both apples and bananas and apples. So this is exactly the same. So now that we have created all of these different combinations, if we add them together, we actually get a total of 10 different combinations that she can make out of her total of 5 books. Go ahead and pause the video and complete the remaining questions for section A and B. Click play when you're ready to move forward. If you are given more than one type of item and must choose one of each type, you can use a tree diagram to figure out all the possible combinations. Each branch of the tree represents a possible combination, and the number of branches on the right-hand side represents the possible number of combinations. In this particular case, let's read this example first and determine how many different outfits Sarah can have. So example 2. Sarah is deciding what to wear. She has 3 shirts, 2 pairs of pants, and 2 pairs of shoes. How many possible outfits does she have if an outfit is 1 shirt, 1 pair of pants, and 1 pair of shoes? So we are going to use our fundamental counting principle in order to solve this. But let's start small and then get to the total answer. So we should probably look at shirts and pants first. So we have 3 possible shirts and 2 possible pairs of pants. So we're going to multiply 3 times 2, which gives us 6. However, now let's actually look at shirts, pants, and shoes. So this is actually going to evolve into 3 shirts times 2 pairs of pants times 2 pairs of shoes, which gives us 12 possible outfit combinations that Sarah can wear. Let's go ahead and give a try to practice questions 8.2, found on page 303. Go ahead and pause the video and follow these instructions. Use a tree diagram or the fundamental counting principle to solve the following problems. Once you've solved these on your own, go ahead and click play to move forward. Okay, so first question up. Frank is making a sandwich. His sandwich will have 1 type of bread, 1 type of meat, and 1 condiment. He has 4 types of bread: white, wheat, rye, and a queso roll. Meats he can choose from are chicken, turkey, and roast beef. For condiments, Frank can choose mayonnaise, mustard, vinaigrette, or horseradish. How many ways can Frank make his sandwich? So we're going to use the same principle, the fundamental counting principle, in order to come up with the number of combinations that Frank can make for his sandwich. So we're going to take 4, which are the types of breads, times 3 types of meats, times 4, which are the condiments, which will give us a grand total of 48 ways of making a sandwich. Kind of makes you hungry, right? Let's go ahead and look at our second example. Question 2. Van On attended a trivia contest and won 3 rounds. For the first round she won, she could choose one of 3 restaurant gift certificates. The prize for another round was one of 2 t-shirts. Winning the third round allowed her to choose one of 4 souvenir hats. How many possible combinations of prizes were available to Van On? So 1, what a lucky person. I can't even win once. And there we go, winning 3 times. So let's go ahead and solve for this particular amount of prizes, or combinations of prizes. So we're going to follow our fundamental counting principle once again. We're going to take 3 restaurant certificates times 2 shirts times 4 hats. This gives us a total of 24 combinations of prizes. Alrighty, you know what to do. Go ahead and pause the video and complete the remaining questions for sections A and B. Once you've completed those on your own, click play to move on to lesson 9. We are almost at the end, everyone. Let's go ahead and move on to lesson 9, permutations. All right, everyone, we're almost at the end. I promise we have 2 more lessons. So let's start with lesson 9, permutations. On the mathematical reasoning test of the GED, you might be asked how many possible permutations or sequences are possible given a group of items. So permutations, also known as sequences, are utilized to find the number of possible outcomes when the order is important. That particular piece of this statement is the most pivotal. So remember, the order is relevant. Let's look at an example. Example 1. Eliza is planning her day off. She wants to visit the art museum, try the new coffee shop, call her mom, and take a walk, but not necessarily in that order. How many possible sequences of those 4 activities are there? So this question is asking you for all the possible permutations. So it could be like coffee, art, mom, walk, or art, coffee, mom, and then walk. There's a lot of different things that she can do with just these 4 activities. Now, consider how this particular problem is different than the combination problems that we previously discussed. In those cases, kind of like the sandwiches or the combination of outfits, in those cases, the order did not matter, but here it does. To find how many ways you can sequence all of these items in a list, we're going to multiply the possibilities in a different way. We're going to start with how many things could go first, as in the very first activity. Here, there are 4 possibilities for Eliza's first activity. Once she has done that first activity, 3 possibilities remain. After she has done a first and second activity, 2 possibilities remain, and then only 1. So she could go to the coffee shop and then call her mom, take a walk, and then visit the art museum, and so on and so on. But again, that's just one example. So let's take a look at this. With step 1, we're going to start with how many things could go first out of the entire list. We have 4 different activities, so technically 4 different things can go first. After that one activity is done, then we have 3 remaining, then 2, then 1. So step 2, we're going to work down the list of possibilities. And finally, step 3, we're going to multiply. So we have 4 times 3 times 2 times 1, which gives us a total of 24 possible permutations. Now let's keep going in the lesson and kind of dive a little bit deeper into what this means. Example 2. 10 runners are competing in a race. There are prizes for first, second, and third place. How many possible sequences of the top 3 prize winners are there? Notice that in this example, you are not trying to solve for how many groups of 3s can be made out of 10, but rather you are solving to determine how many sequences of 3 can be made out of 10. Therefore, the method that we used in the prior example will not work here. And you cannot necessarily just multiply 10 times 9 times 8 times 7 and so on and so on. Instead, we need to determine how many people could win the first place, which in this case is 10, and how many people can win the second place. Once someone has won first place, of course, then there are 9 possibilities of whom can win the second place, given that there's 10 runners total. Once someone has won first and someone else has won second place, there are now 8 possibilities for the third place. So this takes us to 10 times 9 times 8. This then gives us a total of 720 possible ways that the runners can be arranged in the top 3 prize-winning slots. We are now moving forward to practice 9, which you can find on page 305. At this time, go ahead and pause the video and use these instructions. Read the problems and decide whether you are being asked to find combinations or permutations. Then solve. Once you're ready to review it together, go ahead and click play. Alrighty, practice question 1. Noemi is trying to remember the password for her email. She knows that it has the following characters in it: the letter M, the letter Q, $, the letter L, and the number 7. But she can't remember the order they go in. How many possible sequences of those 5 characters are there? So remember that we first have to determine whether we're looking for a combination or a permutation, and then of course we're not going to solve. Given that we're specifically talking about an email password, we can determine that we are looking for a permutation, given that the order of these digits or characters does in fact matter. So now let's go ahead and solve for it. So we have 5 different possible characters. Once 1 is used in the first slot, then it kind of decreases, kind of like our prior example. So we have a total of 5. We're going to then multiply by 4 times 3 times 2 times 1. This gives us a total of 120 possible sequences that Noemi has to try in order to access her email. That's quite a bit of a large number of possibilities, and there's a good chance Noemi's probably going to get locked out of her email. Nonetheless, you can replace this particular example with really anything else, but as long as we need to know an order, we know that it is a permutation. So let's look at our second example to see if it's similar or different. Question 2. Bilal is going to the museum. She wants to see the contemporary art exhibit, the Impressionists, the Greek vases, and a special Picasso exhibit, but not necessarily in that order. How many sequences of those exhibits are possible? So, I mean, it really says it right in the question that the order of this does not matter. Therefore, we can determine that it's not a permutation that we're looking for, but in fact, we're looking for sequences of 4. So we're trying to determine how many different combinations she can make of different paths that she can take in this museum. So this is really similar to the prior example that we had of someone taking a day off and wanting to do 4 different things. So we're going to follow the exact same steps. So we have 4 possible combinations, 4 different activities that we can choose from. Once one of them goes first, then it only leaves 3 other ones to go second. Once those are done, it then only leaves 2 to then go second, and so on and so on. So we're going to multiply across the board. So we have 4 times 3 times 2 times 1. This gives us a total of 24 different sequences of exhibits that she can take at the art museum. We are so close to the end, everyone. Once again, go ahead and pause the video and complete the remaining questions for sections A and B. Once you're ready to move forward, click play. Hey there, I just wanted to go ahead and check in. We are now about to come up on 1 hour of covering this chapter. Now, as you know, the videos were originally not meant to exceed an hour, but this chapter is particularly long. So we still have a little bit left to go. Go ahead and keep pushing through. We're almost there. Now let's move on to lesson 10. Compare proportions in different formats. All right, we're finally at our last lesson. This was like the longest chapter ever. I'm sure you feel the same way. So let's go ahead and finish strong on our last lesson. Compare proportions in different formats. The magnitude of 2 quantities can be represented in multiple ways, such as digits or simple numbers, graphs or charts, and of course dimensions or diagrams. So while the proportion can be represented in multiple ways, its magnitude does not change. However, at times it can be difficult to compare multiple quantities when they are presented in different formats. Therefore, it is important to translate them into the same format in order to solve. So let's go ahead and take a little stab at this in our next example. Example 1. The bar graph shows the number of accidents for men and women aged 18 to 35 in Tabular County for the summer of 2014. The following year, the county released a report that the monthly rate of accidents for men in 2015 had been 1.6, 2.3, and 1.8 times that of women for June, July, and August, respectively. Of the 6 months reported, when was an accident victim more likely to be male? So if we're looking at our bar graph, we can see that men are represented by the black column and women are represented by the gray column. So visually, we can determine that men tend to have more accidents, but that's not what the question is asking us. It's asking us, in fact, in which of the 3 months there is more of a chance that a man is likely to have an accident than a woman. So let's solve this by doing our go-to steps for each problem. Step 1. Determine the proportion of 2014 male accidents to female accidents from the bar graph. So that means that we're going to look at each month individually. Step 2. We're going to compare the calculated values to determine the greatest proportion of male to female accidents. So let's go ahead and start with June. So we're going to break down each month into a ratio with men over women. So if we're looking at June, we can see that men had 350 accidents and women had 200 accidents. So in ratio format, we're going to divide 350 by 200, which gives us 1.75. For July, men had 450 accidents in comparison to the 200 experienced by women. So using our division once again, that gives us a total of 2.25. And finally for August, we have 200 accidents as experienced by men and 100 accidents as experienced by women, which gives us a total of 2. So again, remember, we're not trying to determine whom has more accidents by month because we can see that men do. We're just trying to determine for each of the months which one is the highest. In which month do we see men having more of a chance having an accident than women? So if we're comparing our decimals, we can see the highest value for the ratio is in the month of July 2015, when men were 2.25 times as likely to have an accident as women. So our final answer would be July. Example 2. The following velocity time graph shows the rate of acceleration of two classic muscle cars. A newer model, the Hermes, is able to accelerate from 0 to 60 miles per hour in 8 seconds. How does the Hermes compare to the cars on the graph in terms of acceleration? So we can see on this graph that we have both the pony and the Firebat. The pony car being represented by a dotted line and the Firebat being represented by a solid line. So like always, of course, we're going to follow our steps to solve this problem. So step 1, we're going to use the formula for slope of a line to find the acceleration. So this puts rise over run. Step 2, we are then going to compare the values to determine which one actually compares. So looking at our graph, we can see that the pony's acceleration is going to be 80 over 10. So how do we determine this? So the rise, that means kind of the slope of the line. So if I'm looking at the pony, which is the dotted line, we can see that it goes from 0 all the way to 80. So this is the miles per hour. It does that by going from 0 to 10 seconds. So in 0 to 10 seconds, it goes from 0 to 80 miles per hour. So again, the rise is the miles per hour, and the run is the time frame. So if we have 80 over 10, or 80 minus 0, and 10 minus 0, we can see that it gives us 8 miles per hour. Now let's look at the Firebat. The Firebat, represented by the solid line, goes from 0 to 70 miles per hour in a matter of 10 seconds. So it's the exact same thing. We're going to do 70 minus 0, 10 minus 0, which gives us 7 miles per hour. Now, we know that the Hermes is 7 miles per hour. Okay, so this is information that we have already been provided. So if we're comparing all of our values, we can see that the Firebat is the slowest of all of the cars. Then we have the Hermes, which is 0.5 miles per hour faster. And then, of course, the fastest of the 3 cars would be the pony at 8 miles per hour. Let's go ahead and get started on our last practice section. Practice 10, found on page 307. Go ahead and pause the video and follow these instructions. Compare the proportional data in the following scenarios. Question 1 is based on the following graph. Once you've solved this on your own, go ahead and click play. All right, everyone, we're finally at our very last question. Thank goodness, because this was a long chapter. So question 1. The two graphs show domestic and foreign sales for a brand of U.S. potato chips. For which year were the foreign sales higher as a percentage of total sales, and what was the difference in that percentage between the years? So you can see that we have a circle graph or a pie chart and, of course, our bar graph. So we're going to look at each of those individually. Now, in the pie chart, we can see that foreign sales are represented by the lighter shade. Visually, we can also determine that these sales make up a fourth of the total sales, or 25%. So if I were to divide the circle into 4 equal parts, one of those 4 equal parts would be reflective of the foreign sales. Now, the bar graph is going to be a little bit different. So we're going to have to take an extra step. Now, in order to get the percentage of the foreign sales, we're going to want to gather the total number of sales between domestic and foreign. So we are going to combine those particular millions of units sold. Looking at the bar graph, I can see that domestic sales went up to about $5.5 million. Foreign sales made up $2.5 million. Therefore, the grand total of sales for 2005 is going to be $8 million in sales. But we're really only focused on foreign sales. So we're going to want to find that percentage. We're going to take 2.5 over 8. Remember, this is our sales number. Then we're going to multiply it by 100 in order to get the percentage. You could get the percentage by dividing 2.5 by 8 as we've done before, but that's going to take a little bit longer and some extra steps, given that 2.5 is a smaller number than 8. So you're going to have to move decimals around, then turn it into a percentage. It's too much. So we're just going to go ahead and take the easy way out. So if we take 2.5 over 8 times 100, we get a total of 31.25%. Now, the question is asking us to find the difference in percentage between the years of 1975 and 2005, but just at foreign sales. So this means that we're going to take 31.25 and subtract 25. This gives us a difference of 6.25% in sales. Thus, this is our final answer. All right, for the very last time in this video, go ahead and pause the video, complete practice questions 2 through 4, and click play when you're ready to move forward. Great job, everyone. We made it through chapter 4, which I believe is our longest chapter thus far. So great job. Now we're going to go ahead and move on to chapter 5, Algebra Basics, Expressions, and Polynomials. See you there. Bye-bye.